Today's video will demonstrate how to create a SPY double. Hello, I'm James Helfrich. There are several types of doubles. Each one of them is designed to help us to isolate one class from another class to create a unit test. One of these is called a SPY, and a SPY is useful for determining how a given element is used within another class. Today's video will demonstrate how to do that. We call it a SPY is a double which monitors how subjects utilize a principal. In other words, if one function or method utilizes a data type, we want to see how that data type is used. Now, a SPY does several things. First of all, it implements all the interfaces of the principal. It behaves exactly like the data type that the function or method expects. A SPY contains counters which record how the subject calls the principal's methods. Every time the subject calls a principal's methods, we increment the counter. And finally, the SPY contains a mechanism to report how it is being used. This is best explained by example. I've created a SPY specifically for monitoring how sorts work. Now, this SPY has a default and copy constructor, of course, as a lesson operator. And every time the lesson operator, my compares attribute gets incremented. And every time my assignment operator gets called, my assignment attribute gets incremented. I have ability to reset my counters. And then I have a method to report how each of it is used. Now, to test how this works, I have a binary sort. This binary sort is going to sort elements in an array. The number of elements in an array is just going to sort them. I also have a bubble sort, and I have a heap sort, and I have an insertion sort, and a merge sort, and a quick sort, and a selection sort. And I would like to see how each of these is being used. Now, I wrote some little code to facilitate this testing. Okay. So how many numbers do I want to sort? Let's say 20,000. When I hit enter, it's going to say, hey, how do you want to sort them? I'll say random. And now it's going to go through and call each of these sorts in turn. Now the bubble sort took 2 seconds, the selection sort took half a second, the insertion sort took half a second, and the binary heap merge and quick sort all took less than a hundredth of a second. Now, here's where the SPYs come in. The SPY is going to count how many times the assignment operator was called and how many times the comparison operator was being called. Now notice we have a large number of assigns called by the bubble sort and a large number of compares. We have a small number of assigns and a large number of compares. This because the selection sort is going to spend a great deal of time finding which ones to swap, and then the swap itself is performed a small number of times. The insertion sort, on the other hand, does a large number of assigns and a relatively small number of compares. The binary sort does the smallest number of assigns and compares, even though it takes a bit of time. And the heap, merge, and quick sort all take a relatively small number of assigns and compares. Now, let's run this program again, and we're going to use a different value here. And this time I'm going to do 40,000. And we expect the bubble sort to take 4 times as long, the selection and insertion sorts take 4 times as long, but the binary heap, merge, and quick sort to not take that much longer. And sure enough, it does. And you can see once again that the bubble sort and the insertion sort take a large number of assigns. The bubble selection insertion sort takes a large number of compares, but the log n sorts, the binary heap, merge, and quick sort, all do a small number of assigns and a small number of compares. And this is the advantage of a SPY, is I can take a look inside the algorithm and see exactly how they're utilized. This is the SPY section of the Unit Test 2 chapter of the Software Design textbook.